Good evening, everyone. Here we are, Group 3, to present a project on aircraft delays. Let's talk about delays. Who isn't frustrated when there's a delay with their flight? Everybody is. More frustrated when you have planned your flight to align with your activities once you arrive at your destination. Flight delays are estimated to cost airlines $22 billion annually in the United States, according to Federal Aviation Administration. This is largely due to the fact that airlines must pay federal authorities if planes are left on the runways for more than 3 hours for domestic flights or 4 hours for international flights. Passengers are also inconvenienced by flight delays. A delayed flight can be especially costly for business travelers, as it might be cause them to miss appointments and interfere with other obligations. Here we are defining and measuring delays for IAD airport depending on the data regarding IAD between May to September 2019. We are a group of 4 people, myself, Divya, Vasavi and Jeevan. For our project presentation tonight, this is our agenda. We are taking up the introduction of the project, followed by literature's review section, which will cover major writings and research papers that are similar to our project, the methodology section that revolves around features and model selection and the outcomes of our project and the conclusion. Flight delays have become highly critical topic for air transportation all over the world because of the financial losses that the aviation sector is experiencing. According to the US Bureau of Transportation Statistics, over 20% of US flights were delayed in 2018, resulting in a significant economic effect of $41 billion. Earlier, many research papers revolved around flight arrival and departure delay. One project that helped us while working on our project was Lakshmi and the team in 2020. Using current data, this paper hoped to anticipate the arrival delay of a scheduled individual flight at the destination airport. The prediction model proposed in this paper used supervised machine learning models to anticipate airline arrival delays. For our project, we used three datasets about flights departing from and arriving at Washington Dulles IAD airport in the months from May to September 2019. We hosted all the datasets on GitHub and combined them to perform EDA. To clean the datasets, we removed null values and dropped the columns that are not required for visualization and algorithms. We chose linear regression, logistic regression, random forest classifier, AdaBoost classifier, gradient boost classifier to analyze and predict delays. These algorithms have been used to predict and validate models whose accuracy ranged from 91% to 94%. Model validation techniques like ROC curves were plotted to assess the diagnostic accuracy of the testing set and to compare the diagnostic accuracy of other models that are being used here in this project. There are 5 major hypotheses we are going to discuss in this presentation. Were severe weather conditions affecting the arrival of flights and thereby increasing the delay? Does temperature play a role in the amount of delay that is experienced by flights? Checking efficiency of the percentage of on-time gate arrivals and the percentage of one-time gate departures in each hour. Were the number of scheduled flights and actual flights differing, both in terms of arrival and departures? Is airport weather playing a major role in delays that are being experienced in flights arriving at IAD? And the literature review will be taken by Divya from here. Thank you.
Thank you, Vaishnavi. To talk about the literature review, we looked at almost four other research papers to proceed with our project. Solaki and others used data from Bureau of Transportation and United States Statistics on all domestic flights flown in 2015 to predict whether a plane will arrive on time using machine learning techniques including logistic regression, decision tree regression, Bayesian ridge regression, and gradient boosting regression. One of the outstanding studies in the field of machine learning methods has been a model that uses machine learning techniques to examine delays in arrival planes. This research initially gathered important features which were then used to train both neural networks and deep belief networks with random samples. The model employs memento and resilient back optimized propagation, with resilient back propagating faster than back propagation, resulting in more model training. In this slide, we showed what steps we followed to progress in the project. Just like we do for any other project, we studied the datasets we were provided with. Thank you, Professor, for providing us with the good dataset. We had three data chunks: which had to merge in order to perform an analysis. We discussed the hypothesis in the earlier slides. Then we moved to the feature and model selection, which we would quote at most brainstorming phase. Once we selected what our features would be and what model would be using, we moved to the visualizations. In this slide, we used the data from United States Federal Aviation Administration. The FAA agency is a part of the Department of Transportation that regulates airspace and certifies aircraft worthiness, among other functions. The Aviation System Performance Metrics, abbreviated as ASPM, website contains data on airport operational efficiency from the FAA Operations and Performance Statistics database. The dataset for this investigation came from the Aviation Systems Performance Metrics. The ASPM dataset offers information on the performance and efficiency of 77 airports around the United States. From May through September 2019, we used data from the ASPM Airport Analysis, Airport Efficiency, and ASPM Weather Factors modules in concerning Washington Dallas IAD Airport. The three datasets that we used are daily config, all flights, and standard report. All the columns within these three datasets are defined above in the introduction section. Each of this dataset has a shape of 3672, 20, 3653, 17, and 3672, 20 respectively. When merging the three datasets, the first merge was done on standard report and daily config. The resulting data frame had a shape of 3672, 38. The next merge was done on the merge data frame on all flight datasets. The result of the completely merged data frame had a shape of 3653, 53. This is when it was noticed that the resulting data frame had almost 19 rows missing. The data on this rows could be missing because the flights on during these days might be cancelled or rerouted in a particular unit of hour. Furthermore, we searched for the null values in the resulting data frame and we fill them using a fill method that would address empty cells by substituting the value of preceding cell. After merging the data frame, we would found that some columns had the same values but with different column names. All these duplicate columns were dropped and only those columns that had unique values were retained. The next step, after all the processing and the cleaning was done, the resulting final DF has a shape of 3652, 32. Now this DF was considered for further considerations. Now Jeevan will take care from the next.
Has any effect on the flight arrivals and thereby causes any delay. Let's check this. So we have aggregated the days having the severe weather impact, and we have checked the number of flight arrivals at IID airport, and there is no considerable change in the number of flight arrivals when compared to the no weather impact. We can see the data is here, and we found out that like there is no significant delay due to this severe weather impact. In the next slide, we can see the weather impact on delays. So we also check the total percentage of arrival flight delays due to the weather conditions, and only 3.5% of flights are being delayed due to the weather conditions, which is very less percentage of delays due to the weather conditions. In the next slide, let's check the does temperature play a major role in delay. We have also check the temperature data for each hour, and the trend of delays concerning the temperature is shown as in this slide. From the graph, there is no particular trend we can deduce from it, but the delays, we can deduce one thing, that is the delays are not at the peak when the temperatures are either high or low. Delays varied for the temperature at different times. You can see this from the graph here. And coming to the next hypothesis, now let's calculate the efficiency of on-time arrivals and departures on an average, and check that in each hour from the 5 months of data available for us. These are the efficiency per hour for both the arrivals and departures. And here we can see that efficiency percentage for both arrivals and departures can be derived that 1 a.m. to 2 a.m. is the time where delays are more in arrivals, while 12 a.m. to 1 a.m. is more delay in departures. It can also be derived from the result that morning 11 a.m. to 12 p.m. is the highest average on-time efficiency arrival, while the early morning 6 a.m. to 7 a.m. is the highest average on-time efficiency departure. We can also deduce that the early morning flights we have high efficiency, and the flights which are on midnight we have very less efficiency during the night, midnight. So moving on to the last question we have considered, what is the difference between the number of flights in the scheduled arrivals that have been flown and the actual arrivals that have been flown, and the departures as well. So we can observe that there is a very little difference in scheduled number of flights and actual flights from the figure, but there is a considerable change of 3,000 flights that are operating out of scheduled time. Throughout these 5 months, the number of scheduled flights has been less than the actual number of flights departing from the IID airport. We expected there to be more scheduled flights than actual flights because there could have been unexpected cancellations and delays. These figure, however, proved otherwise. This could be because flights are being flown that are not on the airport schedule. So the next slide, we'll discuss the workflow of our project and how we completed this our project. The first thing we have done is like feature selection. We have done this feature selection with the help of the correlation matrix. To aid us in the selecting the machine learning models, we use the lazy predict module, which Python is offering, and then we applied selected algorithms to analyze the flight delay. Now the next steps will be concluded by Vasavi.
Thank you, Jeevan. Now, when we had to start working on the project, we had difficulties deciding the features and the target variable. So, we found that the correlation matrix would help us gain insights into the relationship between variables. The correlation matrix for all the features is shown in the figure on the slide. We use the Spearman correlation matrix as this would give us a monotonic relationship between all the features in the dataset. Based on the matrix, we decided which features and targets were more important. The features we finalized were the local hour, scheduled departures, scheduled arrivals, and month, and the target variable was the average taxi out delay. Our final data frame was split into training and testing sets, with training set being 80% and the testing set being 20% of the data set. After the split, the first model that was fit is linear regression, which returned an accuracy of 28%. This shows that the model failed utterly in predicting. This happened because the target variable had continuous values in the column, and this caused the model to behave unexpectedly. Next, the training and testing sets were split again, but this time with a lambda function that transformed the target variable into categorical values. If the taxi out time was greater than 1, the delay was considered and a value of 1 would be returned. And if the taxi out time was less than 1, we thought the delay would be negligible and a 0 was returned. Once this split was done, the LazyPredict package enabled the running of all classification and regression models on the training and testing sets to identify the models that would perform reasonably well. LazyPredict is one of the most useful Python packages for semi-automating machine learning tasks. It created many basic models with little code and assists in determining which model functions best without any parameter adjusting. Based on the generated metrics, we selected the k-nearest neighbors, random forest classifier, gradient boost, and AdaBoost to classify and predict. The k-nearest neighbors gave us an accuracy of 91.1, random forest classifier gave us an accuracy of 93.1, gradient boost classifier gave us an accuracy of 93, and AdaBoost gave us accuracy of 93.7. From these slides, we can see that all models comparatively have more true positive predictions when compared to true negatives, false positives, and false negatives. We also used ROC curves to depict the relationship or trade-off between clinical sensitivity and specificity for each feasible cutoff for a test or on a set of tests. We can conclude that there is a balance between the bias and variance for all 4 models, and that we have used in the project. If there would have been any imbalance in terms of bias and variance, regularization techniques like lasso and Rich can be used to get a balance. When we move to the next slide, this slide is more about the final remarks and conclusion. The purpose of this project is to quantify the analysis of taxi out delay and the airport efficiency. The analysis of data showed that the airport weather had a negligible impact on the delays at the IAD airport. Also, we can infer that there is a correlation between airport weather and airport efficiency, but I would say that is not too much of a correlation. Moreover, the ADA boost classifier and gradient boost classifier perform better than random forest and k-nearest neighbors. This project can be further extended to all the other airports, provided the datasets of these airports revolve around the information the datasets that we used in this project have. This project concludes with the model validation and defining the model that performs extremely well for our data. The same data can be fit into reinforcement learning models, and predictions can be made from these reinforcement learning models. Predicting airport performance with a fair look ahead period is a difficult task that has been tried in previous research. A method being proposed by Wang and people on the temporal fusion transformer may estimate departure and arrival delays for many airports at the same time on any future date. This method may capture complicated temporal dynamics of inputs known at the time of prediction and forecast selected delay metrics up to 4 hours ahead of time. Also, as a continuation to our project, the tweets about people on IAD airport during these months that we used in our project can be retrieved using the Twitter API known as TweetPy, and sentiment analysis can be performed on these tweets to know the customer satisfaction on the airport. Similar research was discussed by Utama and others in one of their papers in 2020, where they used the mutual information method for feature selection. And the next slide shows the references we used throughout our project. Now we would like to take this opportunity to thank our professor Dr. Tony Diana for being there for us throughout the project, helping us whenever we were stuck and encouraging us to put our best foot forward. Thank you everyone.